Okay, so opening doors with JSON Web Tokens. Thanks all for coming along. My name is Dechrai. I work for Auth0 as a developer advocate. Does anybody know the difference between developer advocate and somebody in marketing? I give away the T-shirts and stickers for free. Don't have to sign a form for me. I actually do have stickers and T-shirts if you want any. Come see me afterwards in various sizes. I think Dylan deserves one, or maybe all three of them. Yeah, I want to talk to you about JSON Web Tokens, security, opening doors, those kind of things. Let's just get started with the show and see where we end up. Does anybody remember when Amazon Key came out? Does anybody here not know what Amazon Key is? So the other thing that Sonia mentioned in her talk yesterday was that asking people to put their hands up, there's always at least half the audience who go, I'm not putting my hand up, which is fine, I'm not judging. But the hard thing is when you ask somebody to admit they don't know something, it's even harder. And I just saw about 25% of the room's hands go up, so thank you for being honest. And it's helpful for presenters to know how to pitch their talks and how much detail to go into. So Amazon Lock, for those of you who aren't aware, which if I extrapolate that 25% out, is probably half of you, for those who didn't want to raise their hands, was a mechanism designed, I waffle a lot. I should really rein back, shouldn't I? Keep me in check, sir. I also stand in front of the screen. I wander a lot. So if I'm ever standing in front of something and you can't read it, just tell me to shove. It's fine. I'm happy to be oyed at or anything like that. So Amazon Lock, coming back onto topic, was a mechanism designed predominantly for US deliveries. There's a thing that happens in the US, more so than most other countries from what I can gather, where when people get deliveries at their front door, there are some people who drive around in their cars and look out for deliveries and take them. And Amazon wanted to solve this problem. It's a great idea. So they developed their own lock called Amazon Lock. It's an ingenious name. Anybody here work for Amazon? Excellent. Oh, damn, we're recording this, aren't we? So they designed this thing, and look, it's a great idea. The principle was that they'd be able to deliver something on the other side of your door, and your door would then lock again so that nobody could steal it. Brilliant. But in November 2017, which I think was around about 3 to 6 months after it first got launched, some researchers found a bug in the system that allowed people to deliver something and then for it still to be stolen. So let's have a look at how that happened. You have a door. You want a delivery to be made. So somebody comes along in their truck, and they've got this package, and they walk up to your door, and they get out their little device, iPad, whatever, and it connects off to the cloud. Cloud being some kind of Amazon service. It's basically saying, hey, I've got a delivery here. Maybe they do some kind of scanning to verify, and they say, I want access to this door. Amazon know the customer. They know which door to unlock. So they send back a code that gets transferred via Bluetooth to the door. And the door then goes, yep, that's a valid Bluetooth code. I'm going to take that. And then it'll send the code back to the service and say, hey, I've just got this code. It looks valid, but can you tell me whether it's actually valid? Like, double check, make sure, because obviously otherwise you could just send any code in, and as long as it passed some kind of check, then it would open the door. We don't want that. So it does a check back with the Amazon service to make sure that the door is supposed to be opened by the person who's standing there. Sounds great. So the door then opens. They leave the package inside. When they come out again, they can lock the door and walk away. One of the extra security options that you could do was to buy the Amazon Lock camera. I don't know if that's what it was called, but it was a camera that you bought that you'd plug in, connect to your Wi-Fi, and you'd then be able to use a device from wherever you are in the world to see somebody, like in real time, what's actually happening at your door. It's a great extra security feature. So what happened was that somebody found that if you knock out the Wi-Fi, the camera goes offline, the person looking at their device, what do you expect them to see? The last frame captured? Because that's what happened. So the proof of concept was, and I don't think it actually got implemented in real life, but the proof of concept was if I, as a delivery person, go up and I press the button, unlock the door, open the door, put the package inside, close the door, but I don't press the lock button yet, I get a Wi-Fi jammer out, I knock the camera offline, the person who's seen me deliver it sees the door still closed, I open the door, they still see the doors closed, I go inside, they still see the doors closed, I take the package that I just delivered, and maybe their cat, close the door again, press lock and go away, they've lost their package and their cat. Very unhappy. Now, the reason why this probably didn't happen is because to do that, you'd have to be an Amazon delivery employee type person. And if you did that, you're probably going to get fired. And they probably didn't want to be fired unless the cat was very valuable. Not 3 months later, somebody else found a different, they solved that problem, by the way. So the reason why it was the last photo is because it wasn't actually a live video stream. It was a photo grab every, I don't know, second or 10 seconds or something, sent via FTP to a server. And then your device was just looking at the last photo. And it would just get replaced. And it didn't get replaced. So what they did instead was, if they didn't get anything for a certain amount of time, they'd delete the file. And then it's like, there's no photo. Ah, shit, something's gone wrong. That's the solution. And to be honest, I don't know if there's a better solution. Because at least you're aware that something's gone wrong with your system. So 6 months later, this was more of a research thing. I don't think it happened. But this was a little bit more ingenious, and it actually allows somebody who's not the Amazon employee to steal your package. So what happens in this case? You've got your door. Before the delivery person arrives, whoever it is that wants to get their package comes along. It's in red, because red's an evil color. They come along, and they've got this little box. It can be a really, really little box, and you can hide it inside a lamp or in a flower pot or something. Something that nobody's going to notice. But they leave this little box at the side of your door. And inside it's got a Bluetooth transmitter. But it's currently disabled. It's off. It's also got a Bluetooth sensor, which is just listening out for any kind of Bluetooth radio frequency going on in the vicinity. And then they bugger off. Meanwhile, at some point down the track, delivery driver comes along, and they connect up to the server, and they get that Bluetooth code, and they send the Bluetooth code to the door, and the door then goes and checks, and it unlocks, and that's all fine. Meanwhile, this little box has detected that there's been a Bluetooth signal. It can't read it, obviously, because it's secure. It's a pairing process, right? So it can't read what the data was, but it knows that there was a Bluetooth transmission that just happened. So what does it do next? Turns on its Bluetooth jammer. So in order to lock the door, the person, because they don't know how long the door needs to be unlocked for, the person who's making the delivery will open the door, put the package inside, close the door, and then they'll press the lock button on their device. The lock button will go and use a Bluetooth connection to the door and say, I want you to lock. Then it'll wait for confirmation that the door is locked. Sounds sensible, yeah? What happens if it can't connect because Bluetooth is being jammed? It's never going to get a response. It doesn't know that it's not even getting the message to the door, but it's never going to get a response. So it times out. And what happens in the app when it times out? It says, door locked. So delivery driver buggers off thinking the door is locked, isn't actually locked. Evil red person comes back, opens the door, takes the package, takes their package, walks away. You come home, your delivery's not there, your door's unlocked, but everything else looks normal. They didn't want the cat. There's only two hands, like grand piano one hand and Bluetooth jammer in the other. I suppose you could sling a cat over your shoulder. They probably took the parrot, though. Anybody have parrots? Okay. I'm not sure whether stealing parrots is an offensive statement. I didn't want to get in trouble. I noticed there's some people spilling over that side who might not be able to see the screen. If there's anything important on the screen that happens, rest assured, I do wonder a lot. I'll probably also do an interpretive dance, so you'll be fine. So I was thinking to myself, there's got to be a better way. I mean, first of all, connecting a door to an internet, that doesn't need to happen. I mean, connecting a fridge to the internet is stupid enough. Why would you connect your door to the internet? So is there a way we can do this without connecting the door to the internet at all? Can we secure it in a different way? So I still want to have a mobile app of some sort. Obviously, whoever's making the delivery is going to need some way of communicating this unlock process. So we're going to have this mobile app. The mobile app is still going to connect to the cloud in some way, but instead of generating a code that gets transmitted to the server, we're going to use some kind of identity provider that's JSON Web Token compliant. Hence the title of the talk. Any questions? Thanks for coming in. It's been great. So we get the JSON Web Token back, which we can then transfer via NFC. Sure, NFC can still be jammed, but one of the advantages of NFC is that it's a near field. It's harder to jam. You'd need, if the jammer is further away, you'd need a bigger device to jam the signal. Also, NFC is something that you can connect to most IoT devices, as evidenced by this thing here, which I'm crossing my fingers will work. And then once the code has been sent to the door doesn't actually need to go off to the internet to the identity provider to verify, because for those of you familiar with JSON Web Tokens, there's a signature component. And that signature component can be verified in order to verify that the payload is accurate, which means you can trust the payload. And if the payload gives you the information you're expecting, then you know that it's a good JSON Web Token and you can unlock the door. So you can actually verify a JSON Web Token in a completely siloed environment with no need to connect to an external service to verify that the token is still valid, or was valid in the first place, or even is intended for you, because the JSON Web Token will contain information in there that tells you whether or not you are the intended recipient of that information. So let's delve down into a bit more of the technical things, and this is where the interpretive dance will come in. So how does the solution work? You've got a mobile device over here. I don't actually dance, I just prance. We've got a device over here, and then you've got the identity provider. The identity provider is somewhere else in the cloud, and then down at the bottom you've got a door. Imagine the door is just an API. What I want to do is send a request to this door to perform some kind of action. I want to post to /unlock, for example. So we have the mobile device that will generate, so we're going to be using Auth Code flow with PKCE. Hands up who understands exactly what that means. Good, not many. It's fairly new, and I'll go into some depth of how it works. If there are any questions, just ask me at any time, ask me at the end, whatever. It's a newer way of making sure that the data that's being passed around is actually intended for the recipient. Top level overview, let's drill down. So we generate two codes. Basically, you've got a challenge and you've got a solution. The solution, to all intents and purposes, is basically a random string, a random value of some sort, ideally cryptographically secure. And then the challenge is the hashed version of that. Now, we all know that hashing is easy, but unhashing is mathematically improbable. So the first thing we do, the one with the question mark up there, that's the challenge, that's the hashed value, and the one underneath is the unhashed value. So a mobile device, when mobile devices use Oauth OpenID Connect for identifying themselves to an identity provider in order to get tokens back, it'll do it through the built-in browser. So it's not the app that you write yourself. We're looking at a native app here. It'll spawn basically a browser instance in order to present the web page that's going to allow you to log in. So we launch this browser instance, and into it we pass the challenge solution, the thing that's really hard to be able to reverse engineer. Then the request goes off to the identity provider with that challenge solution, which the identity provider will remember. And it's going to respond with a login form, because it doesn't know who you are yet. If you're already logged into the identity provider, it might skip this step, but at the very least now it knows who you are once you actually log in. It knows who you are, and it has this challenge solution. This is the proof key. So PKCE is proof key for certificate exchange. This is the proof key, and it's going to allow us to prove that we are the intended recipients for the token. So it's got this, this challenge, and it knows who you are, who's logged in. So then it'll create the auth code. So the auth code is something that's not specific to you at all. It doesn't contain anything inside it that is in any way related to the person logged in, with the exception the identity provider will remember that for a short period of time, so that in the future somebody can exchange that token, that auth code, for actual tokens. And we'll see how that happens here. So we generate the auth code. And the auth code gets sent back to the browser that's been launched by the native app. And the browser then, having done its job, having logged you in, will return that auth code back to your app. So your app now has an auth code, which says nothing about the person who's just logged in, but it also has this solution to the challenge. So now your app can make a direct request directly to the identity provider. It doesn't need to go via the browser anymore. It's like a direct socket connection. And it'll send through the solution as well as the auth code. So what the identity provider can do now is, having had the challenge and knowing what the hashing algorithm was to generate the challenge, it now has the solution and can confirm that if you apply the same hashing algorithm to that solution, you'll get the challenge. So it knows that the request coming in is from the person who knows what the solution was. Does that make sense? So we're proving now that this device over here is the one that is intended to receive the tokens. So this has been added into Auth Code recently, and it's especially useful in things like single-page apps and native applications, where a lot of your business logic is in a device that you can't control. If you're doing server-based, like if you log in via a server and then you go off and try and get tokens that way, it's not as important because the code is in to all intents and purposes, a lot more secure environment. It's one that you control. I can't right-click view source the contents of your server-side code. But where we're putting code out into devices or into browsers, it's a bit more important. So being able to verify that the solution is correct, and also verifying that the auth code that is received back is correct. It can say, well, I know I issued that auth code to Ben, therefore I'm going to create an identity token and an access token that represent Ben, and then I'm going to send those back to the device. So the device now has an identity token and an access token. Identity token tells it who I am, what my profile information is, which for this purposes we don't necessarily need, and an access token. An access token is what you can use to send to APIs to be able to say things like, I want you to perform this action on Ben's behalf. So now we can just make a single connection to the door via NFC, pass the access token over, and the door can evaluate that access token, verify that it's valid, and unlock the door. Simple, right? All right, let's have a look at demo 1. Whew. Let's see. So I have this running already. Let me just close that because it doesn't like it when I have that maximized. And make that a bit bigger. Can everybody see the eyes? There'll be stuff arriving at the bottom which will eventually push its way up, which you might be able to see slightly over the top. I wonder whether I can move this a little bit further. Open heart surgery? Got nothing on this.
Ben, just wanted to confirm the door's not calling the identity provider when it's checking the access code, right?
Correct. So the question was, the door is not calling the identity provider to check the access code. The access, so there's two. There's the auth code and the access token. The auth code is what the mobile app uses. And the token is then used, sent by the mobile app to the door. The door then can look at that token internally without having to make any external connections. Now, when I say this door is not connected to the internet, that's technically not true, because if it wasn't, I wouldn't be able to SSH in and do this demo. But theoretically, if I turned the Wi-Fi off and still had the Python script running in the background and did this demo, it would still work, I just wouldn't be able to show you what's going on behind the scenes. Right, let's see if I can get Visor running, rerunning. Oh, it's giving me a frowny face. Oh no, there it is. So, open sesame. I came up with this branding myself. What's the difference between somebody in branding and design and developer advocate? Free t-shirts from developer advocates and shit design skills from developer advocates. So, oh, it's gone already. Come back to me. There we go. So I've developed this really, really complicated application. I basically stole the Auth0 SDK and some random code I found on some website, probably Stack Overflow, that allows me to write to NFC. Let's have a quick look at what that looks like, if I can find Android Studio. So I've configured this so we've got the strings XML document basically contains the information that we need to talk to the identity provider. So we've got the client ID, the domain that we're going to be connecting to, and the app name, you know, because we need that. And then the actual code itself, if I can find my mouse. So I won't go through line by line because I don't want to send you to sleep. I mean, that's what lunch is for. Lunch gives you the carb coma, not this talk. But essentially, we have a number of key points. We've got the login button. When you click on the login button, you call the login function. We create a new Auth0 object here. And then when we, which will be used for the login, and then we've got a write button, and the write button becomes active when we get the JSON Web Token back, and calls this. So Toast is the class that I found that writes to NFC cards, and calls the make text, and then write function. No, sorry, Toast is not that. Brain's not working. Toast is the little display thing at the bottom that says, hey, this was successful, which interestingly in my demo doesn't work at the moment, but that doesn't matter. Can you tell this is going to go well? So we've got the write function there. That's what does the NFC stuff. And if we come down to, so there's the login, which is basically just setting up the WebAuth provider. And write basically uses the NDEF message object to take the text and write it directly to the NFC card. So I have a NFC card here. One of the things that I found when testing early is you get free NFC cards when you buy NFC readers. They usually have a very small amount of user data, nowhere near enough to store a JSON Web Token. This is the largest device storage, user storage device I can find, which has got 888 bytes. That's a lot, isn't it? 888 bytes. My average JSON Web Token is about 780, so it just about fits. So there's that code. And now let's break this out and look at what we're doing on the Pi. So I was talking about how the token gets validated. There's two ways of creating a signature for a JSON Web Token. HS or HMAC 256, which is a pre-shared key. Every system that needs to generate a signature to verify a token needs to know what that key is. And then you've got RSA or RS-256 hashing, which is a public-private key mechanism. The advantage of RS-256 is that if your application has access to the internet, you don't need to tell it what the public key is to verify the signature. Who's familiar with the concept of a well-known address or well-known URL? So you'll see these in things like, so for the recording, that was probably about 10% of the people. You'll see this in things like configuration. You'll get configuration files that will allow you know when you open up an email app and you put in your email address and it'll automatically work out which server it is and which port it's on. That's a well-known address. So you go to a certain URL that's fixed and there's a standard for it and it'll give you information about that service. There's one of those for OpenID Connect. So knowing that the issuer of the token is bendechrai.auth0.com, it can go to the well-known URL for that identity provider endpoint and it can get all the information back, including the public key. So your application doesn't need to know what the public key is. But of course, the door is offline. So we're putting the public key into the application here. If you're developing a system that's not offline or in a siloed environment, you don't need to do this. But for the purposes of this demo, we need that in there. Then we're going to set up the GPIO. So that's all the pins on the Raspberry Pi. And we're going to set, we've got a servo lock position, servo unlock position. We're just going to lock it by default. And you'll notice for those who have done any kind of Pi coding before, Raspberry Pi coding, I'm cleaning up the GPIO here, which means I'm actually disconnecting and I'm stopping sending any signals. The reason for this is because the servo uses pulse width modulation, which I don't need to explain, but if anybody wants to know more, I can tell you afterwards. It's a way of, the signaling method is not a digital signal, it's trying to emulate an analog signal, but because it's not perfect, if I didn't disconnect every time, that bar that's currently keeping the door closed would be jiggling forever. And while that doesn't bother me so much, it's really distracting for you. So I thought it was probably better to do that. So we basically got a loop. We read from the NFC card, we decode the JSON Web Token, we print it out. That's basically so you can see what's going on under the hood. We work out how long it still got to expiry. We don't need this programmatically. We can ignore that. Again, that's for display purposes for the demo. We printed a success message for the demo. And most importantly, we unlock the door. Now, you'll notice there's no checking in there to see whether the expiry is valid, whether it's expired already, any of those things. It's because the class that we're using to decode the JSON Web Token will throw an exception if there's anything wrong with it at all. So we can assume that the code will flow through, that everything's fine. If the token has expired, then we'll verify the JSON Web Token again to get some information out about it, but we're going to pass in a message saying we don't actually care whether or not it's valid. And the reason for that is that I still want to find out what the expiry on that is. In the first instance, because I threw an error, we don't actually have the data in the payload of the JSON Web Token, so I still want to pull that out. So I can display on there saying, this token is invalid, and it expired this many seconds ago. And then we'll make sure the door's locked. And then just some other stuff, like if the value that comes through and doesn't actually look like a JSON Web Token. Right. I'm mostly padding for time because I'm really not sure whether this is going to work. Let's just bite the bullet and we'll run poll NFC. Oh, something moved. That's a good sign. Right, so let's just get this back up. Unlock. Oh, it's on a bit of a go slow. Everyone's having a slow day. It's Friday. All right, so come on. So the door's going to work fine, but you just won't be able to see what's going on my phone. Is that right? Is that what you're going to do to me? Anybody got any good jokes?
I hear you know how to dance.
You hear incorrectly. All right, this isn't going to work, so I'm just going to hold it up so you can see what's kind of going on. So you saw before that you might remember before from when I was holding it up, when it was actually on the screen, that the login button is active and the write button is inactive. So if I hold this on there, I just felt a vibration. So I'm going to hit the login button. And because I already did this test earlier, I'm already logged into the identity provider. It's going to come straight back, and I think somebody in the front row can confirm that the bottom button just became active and the top one just became inactive. So now I'm going to hit the create door pass. What's happening now is we're running that write code, which is sending the JSON Web Token to the NFC card. Login button has just become active again, so this card now has the JSON Web Token on it. I do really want to get this working, but it doesn't seem to want to let me, because then I can actually show you what's on the NFC card. Hey! Right. So let's just switch to this NFC card reader. Hold that up there. And we have a look at the NDEF. So this is the user data. Unfortunately, I can't make this any bigger for those of you at the back, but this part here, the text starts EY. That's basically the base64 URL encoded version of an open squiggly bracket. Is that the technical term? Open brace. And down here, we've got the JW, which is the close brace. So that's the start and end of, actually, no, that's a lie. There's a dot in there somewhere, because that's the signature. But anyway, so there's the JSON Web Token on the NFC card. So it really doesn't like me. So if I come over here now, and I want access to this door, I hold this NFC card up to the door, and I move out of the way so that those who can actually see the screen can see what's going on over there. We'll see that the text is way too big. Let's make that a bit smaller so you can actually see what's going on a bit better. How's that? That's, ooh, just the right width. So we can see there at the moment it says, for those who can't see but can just see my backside, it says access denied, token expired Friday the 18th of October at 2:12 in the morning. This is GMT time, which was 54 seconds ago and is currently counting up. But you'll notice that the token is still readable. So this is where we're doing that double check, and we're doing the we don't care whether it's valid or not, we just want to know what's in the token. And in there we can see the subject. So the subject is a representation of my identity. Whenever I log in, that will always be the subject that you see. So if you're writing any applications where you need to manifest a user within your systems, then that's the unique identifier that you can use. Anytime that comes back, you can remanifest the same user out of your database. We've got the issue time, the expired time. We've got the audience, and in there you can see the Open Sesame scheme. So that was programmed into the application. The native app runs that. The door also is basically an API responding to that URL. So I delayed. The door is validating the audience. It'll do that as part of the library that I'm using, the Auth0 SDK for Python will do that automatically. And if we just break that and have a look at the file again, you can see that this is defined just in there. So that line there defines the audience, which you pass into the verifier. So if it's the wrong audience, it'll say it's not intended for me. So it's an interesting one. JSON Web Tokens are totally plain text. I mean, they're base64 URL encoded, so they're hard for us to see what's going on without decoding it. But any system that gets it has full access to the payload. It's not encrypted. You can encrypt JSON Web Tokens. That's a whole different talk. But you should never put anything in there that's sensitive, because any system that gets access to the JSON Web Token can see what's going on in there. You could argue that, well, that system is still going to be able to use it, because even if they're not specified in the audience, they can just ignore that. But if you think about it, any application that is using it in a valid way is going to want to check that it is the intended recipient of that token. And any system that doesn't bother checking that is probably not going to get the token anyway. And even if it does, it shouldn't be able to do anything malicious with it. But yes, good question. The library does actually check that for us. So let's run that again. And I'm just going to write a new token. Log in. Oh, and by the way, your soldering obviously worked perfectly because it's reading the card. Thank you. Right, create door pass. And I now have 60 seconds to get across the room. Well, across the stage. Are you going to write? Maybe not. Right. So if I come over here now and I take the pressure off the door. Hey! Door's unlocked. So you'll see down at the bottom there, it's giving the expiry still, and that 31 seconds, which is now 27 seconds, is counting down. And if I stand here and waffle for about 22 seconds, which I'm sure you'll all agree I'm quite capable of doing, you'll notice that even if the access card is still held there and it expires, the door is going to be able to detect that and lock the door again without me having to remove the card. If I remove the card now, obviously the absence of the NFC card would cause one of the error points in the Python script that we looked at to execute, which would have locked the door. But because the token is now expired, so one of the disadvantages of this is that if it takes you longer than 60 seconds to get to the door, then you're going to have to reburn that code onto the NFC card. But in many ways, that's also an advantage because somebody's got to be close enough to the door to be able to unlock it anyway. There's no point in somebody having a code for a door if they're more than 60 seconds away from it. So this now creates almost an interactive policy, the way we interact with the system, of creating the card just before you unlock it. In an ideal world, you'd actually be able to just generate the code and send it straight across, but unfortunately, the Pixel 2 doesn't have the right chipset to emulate my fair card. There we go. So that's that one. Let's switch back to here. Demo 1, there's the door. So then I thought to myself, well, that's cool. We've got being able to unlock the door, but we're still putting the full control into the person who's at the door. This is fine if I want to get into my house, but what if I want to let the Amazon delivery driver in? Is there a way that I can allow the Amazon delivery driver to use this mechanism, but for me to control whether or not they're allowed in at that point in time? So you could do that with things like access control rules, so that when the Amazon person logs in, it makes sure they're supposed to be there, like there is actually a package to be delivered. But the other thing that I then thought is there's a new flow that's come out, an authentication flow that's come out recently. Well, it's been around for a while, but it's become a lot more common to see it happening. It's called device flow. Has anybody here not heard of device flow? This is a really fun one. It's the one that allows you to log into systems without having a keyboard, which is very useful when you're trying to log into your fridge. How many people have logged successfully into their fridge? No, mine doesn't connect to the internet either. Again, I have no idea why you'd want to connect your internet to the fridge, but Netflix is a really good example of that, or any kind of gaming network where you've got to log in and your screen is your TV and your input controller is like a joystick. Anybody logged into one of those before? You know how you've got to go up, across, click, down, right, click, and then the person next to you goes, I know your password now. So this tries to solve that problem. So I thought the downside with that is we are actually going to have to connect the door to the internet again. So how does this one work? We get a camera, because obviously we need to know who's at our door. The camera doesn't necessarily need to connect to the internet. We can do this without. I was thinking we could probably use Bluetooth for this. Because I, as a delivery person, am going to have my device and I'm going to be near here anyway, I might as well use Bluetooth because we don't care about the security of this anymore. We don't care about Bluetooth jammers because either the video stream is going to work or not. And also NFC is a really poor communications protocol for video. You might be able to get, I don't know, one frame every 2 minutes, just 2 years. So still use that Bluetooth connection. The camera then talks via my app and sends it off to the cloud, which then the person who owns this door can see what's going on. If it gets knocked offline, there's no video feed, so that's fine. But then I wanted to have some kind of mechanism where the person who's looking at the feed is then interacting with that authentication flow. And device flow is a really nice way of doing that. So, queue smooth transaction to a completely different presentation. We'll edit this out in post, I think. Is that right? Yeah, cool. Right, device flow. Where's my clicker? All right, so here's my fridge. It's not my fridge. I don't have an interconnected fridge, but let's say that this is the door. And here's the device that we're going to use to log in to the door. Actually, no, this is the device that the person who owns the door is going to have. And then we've got our identity server over there. So in this particular instance, the person who wants to make a delivery doesn't actually need a device as such. All they need is some way of starting the device flow process, which could just be a button. And then the Raspberry Pi, being the door, will start the device flow process off. So what happens under the hood? The door, or the fridge, will make a request to the identity provider, and it'll send through the client ID. Client ID being the thing that tells the identity provider what system is trying to log into. or trying to be logged into. The identity provider, knowing there's a device flow request, is going to respond with a bit of JSON that'll help the device at the other end do what it needs to do to get authentication. So this bit of JSON in here is going to contain a device code. This is a unique code for the door. Any further communications from that door, it'll say, here's the device code you gave me. So now there's that link between the door and the identity provider. We have a user code. So you know when you connect, I don't know, Google Chrome to your TV, if you've done that, you'll get the 4 characters in the bottom right-hand corner, and that's the thing you need to verify. That's kind of like the user code. This is the thing the user gets that they need to verify is the same in order for the authentication process to continue. It doesn't solve the authentication process, but it's just a connector between the user and the identity provider. We also have a verification URI. This is the endpoint on the identity provider that the user needs to hit in order to authenticate to connect the door to the identity provider, or the fridge in this case. We've also got a complete version. So this is going to be the verification URI plus the user code. It's just in a convenient single variable that you can just pump out as a QR code or something, so somebody can just scan it. The whole process has an expiry. You'll have like 3 minutes or something to complete the process, otherwise the thing times out. And it also returns an interval. This interval is a value in seconds, and it's advising the fridge or the door to connect every X number of seconds back to the identity provider to see whether or not there's a token ready for it. Make sense? We'll see the loop close in a second. So we've got this information in the door. The door then starts on that interval every 5 seconds, for example, making a request to the identity provider saying, hey, here's my device code. Do I have a token yet? And the identity provider's like, hold your horses, mate. I only just sent you the code, and the person hasn't even clicked the button yet. There's nothing to see here. So it'll carry on doing that every 5 seconds, or whatever the interval was set up at. Meanwhile, the door or the fridge is going to find some way of communicating that verification URI and the user code to somebody who's going to have access or authority to unlock the door. Or unlock the fridge. I don't know. Why are fridges internet connected? Anyway, I'm going to change that image for door. So this in here contains just the user code, the verification URI, and the convenience full complete URI that the user can then use. So they'll then click on that link, or they'll scan the QR code, or whatever it is that they do. And by doing that, they'll be making a request to the identity provider. There's a little gray line over here, which is the login process, but let's assume they're logged in already. At this point, the identity provider says, I've just received a request on a verification endpoint that I've been expecting from somebody who's authorized and logged in. Therefore, the next time line 3 happens, next time the door says, hey, do you have a token? The identity provider is going to say, hey, yeah, I've got a token for you. Passes the access token back, and probably an identity token, maybe, of the person who just logged in, which can then be sent to whichever API. Now, in this case, the door doesn't need to talk to another API. It's just going to use that access token, and if it gets one, it says, OK, I'm going to unlock. Does that make sense? Any questions about device flow? So the thing I really love about this is that the only communication here, it doesn't even need to be digital. It can be display a QR code on the fridge door, and you just scan it with your phone. It could be, I don't know, text to voice, and it'll read a code out to you and tell you to go to HTTPS, sorry. But I love the fact that these are separate. Like, they could even be geographically separate. Maybe the code gets sent via SMS. So you could be on the other side of the world, which helps us unlock the door when we're not at home. So let's switch back to, let's try and use my laptop. Let's close that. Back to this one. Right, so as you can see, I seamlessly transitioned directly back into this presentation. Again, design, branding, totally on brand. It's working well. So I'm going to do something slightly different. I've not done this before. I've done the device flow, but I'm hoping that this works. Let's see how we go. Let's first of all go and have a look at the code. So this, rather than being a polling script, is a server that runs in the background, because it's just going to do a single process and then close off. And if we have a look from the top, we've got the public key in there again. Essentially what we're doing, and if you remember back to what I just showed you in terms of the flow of device flow, we're making a request to the identity provider saying, give me information, I want a device flow auth setup. We get the device config, we're then going to print it out, And there's this barcode.techit.com URL, which will, if I click on it, will give us a QR code of it. Some of you might be able to see where this one's going. And then we're going to try getting the tokens out. We're going to get the ID token, the access token, and basically we're just going to print out a bit of information and then unlock the door. Like I said, if we get the token and it verifies, which is implied within the reading by using the library, then the token is valid, therefore we're going to unlock the door. Right, let's run this. So it's making a request in the background. So we've got the device code out. The interval is 5, so every 5 seconds, you'll see another set of eyes coming up. And that's basically polling the identity provider, saying, is there a code? And then you see the thumbs down. Nope. And here's the verification URI. But if I click on this link here, and somebody in the audience gets their phone out and goes to the URL represented by that QR code and logs in with the username owner@example.com and the password. And I stand over here and just look awkwardly while that hopefully happens. This is how I pad out all my talks.
Invalid or expired user code.
I wonder. Yeah. All right, let me open that one. So did you get that far? No. Yeah. All right, well, I'll just log in then. Owner@example.com. And password. Is it going to go? Yes, congratulations, you're all set. And now, so the difference here is it just closed itself as well. If we just switch back to the code and have a look at what was going on in the background, if I can find it. So we got the token through. We got the identity token up there and the access token. The token had the issued at timestamp, which was at 2:28 in the morning in UK, and the expiry, which was 1 minute later. So you can configure how long you want these tokens to last. In our case, we actually only needed for like the 2 seconds that it took the Python process to process it, to determine it. And then because the code was valid, it unlocked the door and then did a 5-second countdown before locking it. Because using device flow, there's no simple way of interacting with the door again to trigger a close. Now, what you could do is if you wanted, because obviously 5 seconds is not going to be long enough to open the door, put a package inside, steal the cat and close the door again, is you could have a lock door button, which talks directly hardwired to some of the pins on the Raspberry Pi to lock the door, so that you don't have the issue that the Amazon lock had where blocking Bluetooth stopped the door from locking. And then that way, somebody can arrive at your door, press a button, camera comes on, sends a picture to you. You say, yep, that's cool. Also contains the verification URI that came through. You click on that, you approve it, door unlocks, person puts the package inside, closes the door, presses the lock button, off they go. And you've had full control over whether or not they get access. And even though the door is connected to the internet again still, we don't have any other communications methods that can potentially be interrupted or subverted on the door side that allow somebody to bypass the whole authentication process. Cool. That's all I had. So there are some changes that I haven't committed yet, which I will be doing in the next, I don't know, few days. But these URLs, which are really hard contrast to read intentionally, it's security through obscurity. It's my favorite form of security. Ben Dechrai is my username at GitHub. Opening doors Android, opening doors Arduino, and opening doors RPi. You might be wondering why there's an Arduino package in there. It turns out that when you give this talk at a conference and the NFC card reader dies, and you can't buy the same NFC card reader, you need to buy one that works on Arduino, but because Arduinos have such small amounts of memory, they can't actually hold a JSON Web Token in one go to be able to verify it. So you then just stream that directly to the Raspberry Pi. So that's why that one's in there. So you can have a look at that if you like as well. But don't worry about that one too much. Have a look at the Android and the RPi code if you want to duplicate this. Come up and have a look at the door. Ask me any questions. I'm around for the next few hours. Thanks for your time.